So welcome to this segment of my videos in physics as we continue looking at latent heat. Remember, in our previous discussion we did talk about specific heat capacity. So that is what we talked about. So today we are going to focus on what we are calling as being latent heat. Possibly the question that you may be asking yourself is, what is a latent heat, or what does the word latent there mean? Let's start with the word there itself. Latent, what does this word latent there mean? Well, the word latent simply means hidden. So that is what that word simply means, hidden. It's like something that is actually hidden. You cannot see it. It's there, but you cannot just see it. Yeah, so therefore when we talk about what we are calling as being latent heat, what does that simply mean? Well, latent heat simply means that simply we can say means heat that is hidden. So heat that is hidden, that's what we mean. Or you can simply say hidden heat. That is what latent heat there means. Now, of course, when they tell you in the exam to actually define what we are calling as being latent heat, we can actually define it in this way. So you need to remember, you can also define it in this way. It is simply the thermal energy needed to change the state of a substance at constant temperature. So we can simply say latent heat is the thermal, so we can just say it is the thermal energy needed to change the state of a substance, at constant, so at constant temperature. So now if you look at the definition that I've actually given you that you can use when you're defining in the exam, we're simply saying it's the amount of thermal energy needed to change the state of a substance at constant temperature. So that is what we simply call as being latent heat. Remember, there are three states of matter that normally we talk about. In this case, something can be in solid, something can be in liquid state, or something can be in gaseous state. Yeah, so it can actually be in gaseous state. So now the thermal energy needed to change the state. For example, you want to change something from solid maybe to a liquid, or from a liquid into a gas. So that is what we are calling as being latent heat. But this amount of thermal energy is actually hidden. You cannot see it. That is why we have used the word at constant temperature, because the temperature will not change. So the heat that has been supplied is actually going to be considered to be hidden. Therefore, in the exam, you are going to find a word now that we are going to be using to that latent heat. We are going to say specific latent heat of fusion. So specific latent heat of fusion, which we normally abbreviate as being L and small f there. So what is specific latent heat of fusion? Remember, these are just minor concepts that I'm giving you so that you can actually use them. Well, when it comes to specific latent heat of fusion, remember we're using the word specific, so we are specifying. So specific latent heat of fusion is the thermal, so we can say is the thermal energy needed to change, so it's the thermal energy needed to change a unit mass. So mark that word, a unit mass. So when we say a unit mass, we mean a 1 kg mass, from solid to liquid, at constant temperature. So this is what we call as being specific latent heat of fusion. So It's the amount of thermal energy that is needed to change a unit mass, that is a 1 kg mass, from solid to liquid. So if you want to change from solid to liquid a unit mass at constant temperature, that is what we call as being specific latent heat of fusion. Now the formula that we are going to apply in this case, the formula that we can apply there is that when we talk about thermal energy, so this thermal energy, some books are going to be using the symbol Q, or I'll be using sometimes E. So thermal energy in this case represented, I'll use E, will be given by the mass multiplied by what we are calling as being the specific latent heat of fusion. In other words, E, the thermal energy that is needed, will be equal to the mass multiplied by the specific latent heat of fusion. Now when we talk about specific latent heat of fusion, like I told you, the symbol that we use is L, and a small f there. That is what we mean. So meaning, if I want to find the specific latent heat of fusion, it becomes very simple. Allow me just to clear up the top section so that you are able to see. I try to amplify more on that. Now, since the thermal energy that is needed, E, is equal to the mass multiplied by the latent heat of fusion. If you want to find the latent heat of fusion, it simply means you divide your M there. So you are going to divide your mass. What you do this side, you also do it the other side. So you can see that the latent heat of fusion will be equal to the thermal energy divided by the mass. Now, if you remember, energy is measured in joule, and the mass, the SI unit for mass, is simply the kilogram. So combining that will give you joule per kilogram. That is the SI unit in this case for specific latent heat of fusion. So I can simply say the SI unit that you need to remember in this case for specific latent heat of fusion is simply joule per kilogram. So that is joule per kilogram, joule per kilogram. So that is what you need to remember. Now, just to help you actually understand even that further, understanding about the specific latent heat of fusion, you need to remember, imagine that you have got ice. Let me say you have got 1 kg of ice, because we are talking about a unit mass, and this ice is simply at 0 degrees, and you want to change it to, again, remember the 1 kg will not change, so you want to change it to water. So you want to change it from, in this case, ice to water. But of course, remember, at constant temperature, meaning the temperature should remain still at 0 degrees. So you want to change 1 kg of ice at 0 degrees to 1 kg of water at still 0 degrees, because there's no change in temperature. The thermal energy that you are going to take in to do that, in other words, to melt it, that is what we call as being the latent, specific latent heat of fusion. And this value is normally given a specific value. Of course, if you are dealing with water, the value is about 334 thousand, in this case, joule per kg. So that's the amount of thermal energy that you need. But I want you to be clear again, when we talk about specific latent heat of fusion of a substance, like I said, it is the quantity of heat. So one, it can be the quantity of heat absorbed during melting, or the quantity of heat released during freezing of 1 kg of a substance without any change in temperature. So it could either be during the time that maybe melting is taking place, or it could be when freezing in this case is taking place. So now when melting is taking place, remember, energy has to be absorbed in this case. But when freezing is taking place, what happens to the energy? The heat energy has to be released. So the same amount of energy is going to be needed. So whether melting or freezing, that is going to be specific latent heat of fusion. What is important is for you to remember the formula that the amount of thermal energy is equal to mass multiplied by the latent heat of fusion. Therefore, you can make specific latent heat of fusion subject of the formula. When you make it in this case, you find that it will be just the energy divided by the mass. So these are important concepts that you need to remember. Right, I hope this is helping you, but let me now specifically look at an example so that I can show you how you can actually get to apply the concept there that we have actually talked about. Now previously in my discussion that I talked about, remember we talked about what we called specific, we talked about what we called as being specific heat capacity, where we said that the thermal energy can also be given by mass, the specific heat capacity represented by small c, and change in temperature, so delta theta, which is representing the change in temperature. And if you make C the subject of the formula, we did say that it is the thermal energy divided by the mass and the change in temperature. And this is what we called as being, in this case, as being specific, heat capacity. I hope you remember, specific heat capacity. So that is what we did talk about. So I may be using this formula in my discussion, so I want you to remember that. So let's look at the solution to this one. It says, question number 1 there says that how much energy would be needed to change 3 kg of a solid if its latent heat of fusion is that one. So that is what they want us to do. So now if you look at the data that they have given us there, we do have a mass of 3 kg, that is a solid, so you want to change it into a liquid, and the latent heat of specific latent heat of fusion there is equal to 3.34 times 10 raised to the power 5, that is joule per kg. Then the question says how much energy. So the question wants you to know how much energy. So you don't need to struggle. Remember, energy is equal to mass times the specific latent heat of fusion. So you just need to apply E is equal to, what is the mass? It is simply 3 kg multiplied by the specific latent heat of fusion, 3.34 times 10 raised to the power 5. That is joule per kg. Now if you notice, the kg and the kg will cancel. So therefore E will be equal to, if you multiply that, put it on your calculator, it will be 3 times, in this case, 3.34 exponent, 5 there. So if you work out that one, it is simply going to give you, in this case, okay. So that is giving you a very big value there. So that is giving you that, all right? So that is almost 1,200,000. But we can write that, in scientific notation. So that would be 1.0 times 10 raised to the power, 6. And that is energy, so it is going to be in joules. So that's the amount of energy that would actually be needed to change a 3 kg of solid, into liquid. So that is what you needed to do there. Let's look at another one, which is the second question there. Let's look at the second question there. It says, calculate how much energy is required to change a 2 kg of ice at 0 degrees into water at 20 degrees. Now sometimes it is actually good to actually illustrate what you have actually been given there. So now they want us to change, a 2 kg of ice. So you have got 2 kg, ice, you want to change it from 0 degrees, to 20 degrees of water. That is what you need to do. Now, if it is ice, in this case, step number 1, you need to know how much energy is needed to change. In other words, how much energy is needed to convert 0 degrees of ice, 0 degrees of ice, to 0 degrees of water. And remember, when you're changing from 0 degrees of ice to 0 degrees of water, that is what we are calling as being the latent heat of fusion. It involves the latent heat of fusion. So how much energy do you need there in this case? So you have got from 0 degrees of ice to 0 degrees of water. So there's energy. Let me call the energy that you need there, let me call it as being energy 1. Then again, from 0 degrees of water to 20 degrees of water, you need another amount of energy. Let me call it as being energy 2. So the total energy will be, we are going to add the 2 energy. So let's first of all find energy 1. So in this case, to change 0 degrees of ice to 0 degrees of water, energy will be equal to mass multiplied by latent heat of, specific latent heat of fusion. So what is the mass? Remember, in this case, the second question, it is 2 kg. So we didn't write the data, and they have given us the data there, 3.34 times 10 raised to the power 5, that is joules per kg. So if you multiply that, if you multiply 2 multiplied by 3.34 exponent 5 there, what is that going to give you? It is going to give you 6.7 in scientific notation to 1 decimal place times 10 raised to the power 5, and that is going to be in joules. So this is the amount of energy, let me call it as being E1, needed to change from 0 degrees of ice to 0 degrees of water. The second thing, step number 2, you now need to change, what is the energy needed to change now from 0 degrees of water, you are now here, from 0 degrees of water to 20 degrees of water. So what's the energy in this case? Now the energy that is needed here, we are going to go to specific, what we learned in our previous discussion, specific heat capacity. So energy is equal to mass, specific heat capacity, and change in water temperature. So the energy will be equal to, in this case, the mass is a 2 kg. The specific heat capacity, they have given us the specific heat capacity of water, that is 4,200, that is joule per kg Kelvin. Then the change in temperature, what is the change in temperature from 0 to 20? It will still give you 20 degrees Celsius. So therefore, energy 2, E2 will be equal to, we can actually multiply that, it will be 2 multiplied by 4,200 multiplied by 20. So that is going to give you, in scientific notation, if you look at that to 1 decimal place, it will be 1.7 times 10 raised to the power, again, 5 joules. That's the energy needed to move from, again, 0 to 20. So now you can now find the total energy. So once you know energy 1 and energy 2, we can now find the total energy. Let me just use a blue marker so that you are able to see. So I can simply say the total energy will be equal to E1 plus E plus E2. So in this case, what is my E1? Remember, our E1 was that one, 6.7 times 10 raised to the power 5 joules, plus again E2, that is 1.7 times 10 raised to the power 5 joule. So when you add that on your calculator, if you add that, it is going to give us 8.4 times 10 raised to the power 5 joules. So this was the total energy that was needed. Of course, if you are struggling there, you don't need to struggle. That one is simply 6.7 exponent 5 exponent 5, then plus, in this case, 1.7 exponent 5. Can enclose that. You can see we're having that, and if you write it in scientific notation, it will give you that. So watch out for some more questions as I try to give you a lot of concept on this specific latent heat of fusion.